Okay, so given the following reaction, we are to calculate the equilibrium concentrations of B2C, AB4, and C2. The equilibrium constant is 243, and we have an initial concentration of B2C of 2 molar. So the first thing I'm going to do is set up my ice table. I already wrote out the reaction, and then I already kind of set up my ice table. So the first row is the initial concentration. So we're just given 2 molar concentration for B2C. So we're not given a concentration because it's a solid and it's not going to be included in our reaction. So we're skipping A, and then next AB4 aqueous is going to be 0 and C2 is going to be 0 as well. The next row is the change. So B2C is going to be negative 2x. And once again, we're not including A. And then AB4 is plus x, as well as C2 is also plus x. Our next row, the equilibrium concentration equation. So it's going to be, for B2C is going to be 2 minus 2x. AB4 is going to be plus x. It's going to come straight down, and then plus x. So here's my finished ice table. So now that we have our ice table set up, now we can plug our equilibrium values into our expression that we're going to make using our equilibrium constant. So Kc is going to equal 243, equal to, we have 2 x's on the product side, so it's going to be product over reactant. So we have 2 x's, so it's just going to equal x squared over 2 minus 2x. So if you notice, we have a square on the top and a square on the bottom. Oh, I forgot to add the square on the bottom. Okay, so now we have x squared over 2 minus 2x squared. So those are 2 squares, so it's going to be a perfect square. So we're going to take the square root of both sides. Let's get rid of the squares. So we're just going to calculate the square root of 243, which is 15.6. So we have 15.6 equal to x over 2 minus 2x. So next we just solve for x. So we have 15.6. We're going to multiply the 2 minus 2x equal x. Gives me 31.2 minus 31.2x. 2x. Negative 32. Okay, and our x is equal to 0.969. Here's my algebra for my x. So now that we have our x, our last step is to just plug in the x for our equations that we created in our ice table to get the equilibrium concentration. So we have the equilibrium concentration equation for B2C is 2 minus 2 times our x of 9.69. And let's calculate that. It's negative 2 times 969. Plus Okay, so our equilibrium concentration of B2C is 0.062 molar. So for both our AB4 and C2, equilibrium concentration is going to be the same. Since they were just x's for the equation we made for them, it's just going to equal our x. So they're both going to be 0.969. So here are my finished concentrations, or my final answers for the equilibrium concentration of B2C, AB4, and C2.